Not doing that. Delpy, you're recording.
Good morning.
Say good morning. Good morning. Not yet. When I press this button, you gotta be happy and say.
Good morning.
Hello.
What's up, Big Daddy?
Hey, thank you.
You're welcome, buddy.
We got Luke, John.
No, that's my teacher. I like him a little cuter than that.
Anthony.
Mom, what's on my notes?
Got Brady.
Yeah.
Hello.
Hello.
I know I haven't had my coffee yet.
Well, you better go get your coffee.
Did you say you're muting me? Because I'll just get off.
Me?
Yeah. You're muting me?
No.
Color.
Oh, okay.
Who did the programming on Monday? Hello.
Luke.
Who did the?
Sorry, I'm bouncing between mute and unmute because of the kids, but
Luke did.
Luke did.
no, Jacob did. No, I guess Jacob.
Wrong class, my bad.
Luke did do it Monday. You're right.
I thought he did it Wednesday.
No, we didn't do class Wednesday. We did motors Wednesday.
Oh, yeah, you're right.
Was Luke?
Yeah. No, you were right. It was.
Did you get a haircut?
Yeah, I was gonna say, John, you look good with that haircut. No homo.
Oh,
That's
appreciate
nice.
it. I had to cut it myself. Natasha,
Looks like a very handsome.
what I messed up.
Well, I'm
Oh,
sorry.
yeah, you
no,
like
it's
that?
fine.
Huh?
But I'm sorry that I was.
Did you get too impatient waiting for barbershops to open back up?
Yeah, it was starting to get too long. Starting to irritate me.
I gave myself a haircut earlier this week.
Looks good.
It looks nice, Zach.
Thank you. Thanks.
You missed a little spot.
Look at the back.
What color are they? The bears?
I tell you what, guys, for real, you can't even find clippers in the stores right now. Even Amazon's out of them till like the 4th of May.
Really?
Yeah.
That's so dumb.
All right, you guys gonna do this freaking virtual graduation shit?
I signed up, but I'm probably not going to show up.
Yeah, that's a little irritating. I'm gonna try to wait.
I still gotta take 245.
Yeah, I still gotta take 2 classes too, so I can hold off.
Whoops. What day was that? 13th.
Hi, Nate. You didn't say hi to me.
Okay, this is what we got so far.
Hi.
Hi.
You're right. We've got everything except for let's look.
You need like another red strobe light or something, right?
Well, we got the strobe. Wow. Really?
What?
We've got the strobe while I don't know. Let's look. Where is that assignment? Oh, it's on Blackboard, isn't it?
Temp sensor.
Two 32. There it is.
Red heater, iron is on the bottom, red PL flashes.
I think we've already got that done. I think we're done. We just have to dial it in. Is that right? To keep the
Yeah,
these two. All right.
yeah, you're right, Zach. Because I remember you saying that last time. You said that we were completely done. We just need to dial it in.
All right. Well, let's.
Yep.
Who are we going to pick on today? I think we're going to pick on Zach. Zach, are you there?
Yep.
Wait a minute. Have you done programming yet?
No, not yet.
All right. You're up, Slugger.
All right.
Okay, you got it. All right. I think I told group 3 or 4 this yesterday, but I ran out of 3-amp fuses. I gotta write that down. So I put a 15-amp fuse in there.
There's actually a book named that.
You want me to send you some, Zach?
Sure. I need but I need you guys to let me know when we're running stuff. If that trainer behind me starts smoking, please say something, okay?
You don't need to.
What size did you put in it?
15.
15?
Oh, I had.
Did you check the amp draw on that sucker? You got an amp clamp down there?
It doesn't matter. I don't have a choice. I don't have any other size fuses, John.
Well,
Lead
I
wire.
understand.
The lead wire is only good for 3 amps. It's 22.
That's why I'm asking if you've got an amp clamp on there to see what.
Nope, sure don't. I'm just taking a risk.
All right, that's fine.
Already have any jurisdiction. Wait a minute, that's me. All right, what are we doing? Oh, Zach, you need to download and run this thing.
Okay.
We'll keep an eye on the temperature.
All right. Sure.
Why is it reading at 2 degrees Celsius? Can you go back up to the rungs that show temperature? Okay, stop. Rung 11, why are we showing F82 is 31,287? Degrees Celsius.
Yeah, we had to do Celsius, and then we had to convert it to Fahrenheit.
Right, but rung 8 is should be showing the temperature in the garage right now, and it's reading at negative 0.26.
Well, I mean, in Fahrenheit, that's 31 degrees. That's in Celsius.
Yeah, I'm not that cold. You know what I'm saying? I can tell you what the temperature is in here. 64.
Oh, well, I don't know that. Yeah, that's odd.
You might have to do some troubleshooting. How should we do that?
Mm,
Come on, class.
What is it displaying? 2 degrees Celsius? I can't see. Well, yeah, now I can.
it's negative 0.26 Celsius, and he said it's 62 degrees in your garage?
62 degrees Fahrenheit. So that puck that thermocouple is connected to should be outputting a certain amount of milliamps, right?
Yeah. So check on, well, will we click on run 8 on the compute function?
What should I do?
No, I'm saying we actually need to get our meter out and check what's going on behind me.
Oh, see how many amps it's putting out.
Yeah,
So right now it's probably less than 4.
yeah,
It's showing negative.
yeah. So somebody tell me which input that is for the air temperature, and I will get out a meter and I will read it.
Hold on, I got the.
We will do some troubleshooting together as a class, as a family.
I prefer to troubleshoot alone. All right, which input are we looking for again? Sorry, the temp in, right?
Air temperature, yeah.
All right, temperature sensor is on 7-1. Slot 7, input 1.
If I put this here, you guys read that.
You already break the circuit?
No, I'm going to check voltage on the puck, see if we got 24 volts.
Oh, okay.
And then I will break the circuit and check current. Can you guys read my meter? Or do I need to be closer?
I cannot. I don't know about everybody else, but I can't because it's on a small screen on my computer because of the
Shared screen.
yeah.
Can you pin the video?
Oh, you can swap them. There's a thing in the corner. Swap shared screen with video.
If I set it there with your video pinned, can you see it?
Yeah, we can. You can see it if you're in full screen. Tilt it forward a little bit more if you can.
Is
Yeah, that's.
besides John paying attention?
Yeah, that's good.
Anybody? 'Cause I'm sure right now you're all pulling up the specs.
I could
Fuck.
Definitely see it. I can see it. I was switching over to my laptop from my phone.
Your laptop?
Yeah, laptop. LAP, DOP.
I don't have the huck pull or the puck pulled up. Is it in the? Do we need the puck pulled up?
Can't see the puck.
Do this.
No, the data sheet's in there. I think you meant the data sheet for the puck.
That's
You know,
impressive,
Zach.
Zach.
What?
The table.
Bless.
Oh, what's yours?
Bless you.
Nice
That's
shoes.
Rona.
Coronavirus.
Yeah, sorry. It's not the Corona. She said
It's
thank
the
you.
Bud Light.
What are you doing? The Bud Light? Yeah, it's the Bud Light.
This guy right here.
Yeah, we have Bud Light Lime in the fridge. This is that.
That you were drinking the other day.
Fuck.
Drinking right now,
Jesus.
What's it reading?
Yeah, what's it reading?
I want you guys to tell me what to do.
So, where's the data sheet for it?
First figure meter on it, so you got to break the circuit.
So you got your voltmeter on it. Put your black lead on the, I'm assuming the white wire, and then your red lead on the red wire. I don't have the data sheet. I'm just looking at a picture of it. I think that's the.
I'm assuming that I got a good 24 volts in because I don't know if you can see it, but there's a green LED indicator light.
Nah, I can't see it.
You can't trust those either, Zach. Those only take like 2 volts to light up.
You see my meter?
Yeah, you're
Yeah,
not reading
It's a
anything.
0.
0.
That's nice. I don't know what you want me to do.
Like, and the only reason I say that to you guys, that you can't trust them LEDs, because I had that where a guy was troubleshooting a solenoid valve with an indicator light, and he said that the output from the Profi bus was good because the light was lit, and they were only getting 14 volts across the solenoid. It needed 24 volts DC. That LED will light on 2.
It's good to know.
Yeah, just you know, in general, you can trust the LEDs, but it's not a guarantee.
Yeah.
Zach, I'm wondering if you do you have your lead in the amp side from like current earlier or something, or?
Well, you're still putting plus 24 onto it, and then the puck itself just monitors or manipulates the current.
No, on your meter. You got your meter leads swapped from checking current earlier or something?
Oh, good point.
What? Yeah, they should be.
All right.
24 volts.
Cool. All right. So, I guess I need to let's see. The blue one is current in. So if I take that all. Oops.
And it's like your whole garage is shaking or something, dude. It's wild.
Somebody check. What is it? 7.3.
Your sleeves. Oh, there we go. It is. Sorry, I just had it pulled up. Let me.
I do believe it's 7-1.
7-1. No, it's 7-3. You're right. Oh, it is. Yeah. They got that written. It is 7-3. Sorry, these are written weird.
Okay.
That I looked like a 1 to me on the screen. I apologize. It is 7-3. I said 7-1. It's 7 input channel 3. My apologies. I got bad eyesight.
Okay, so if I'm reading current,
How come Fluke doesn't like amp clamps?
huh?
I said, why does Fluke Industries not like amp clamps? They like to charge an arm or leg for their meters and put no amp clamps on them.
Okay, I've got
Oh, no.
0.
Didn't blow a fuse again, did we? No.
Oh yeah, we have 24-volt supplied to it. So
Yeah. You're getting 0.022.
So I got 22 milliamps. Boy. What do you think we should do?
So you have 22 milliamps coming into the analog card,
Well, I have
or from the puck.
I have 22 milliamps going to analog common,
Okay.
and I have 0 milliamps going to
Channel 3.
3.
And that's coming from the puck.
Yeah. So why don't I?
Did we check voltage on the puck? It was 24, right?
Yeah, it's 24.
What if we keep our meter on this and
Heat the temp sensor.
yeah, see if we get it to change. We need to figure out if the PLC module is bad, or if the puck is bad, or if the probe is bad. Right? Something's not doing its job.
Yeah, true.
I know I got a good 24 volts going to the puck. It's just not outputting the right current. So I'm gonna put. Whoops.
Oh,
Remind me to
Hey, Zach, you dropped something.
The one input from Brad. You dropped something.
Remind me to quit bumping the chair. I'll put a little scrap piece of wire on the analog input. Let's see if we can get right. Okay, well now I'm getting 5 milliamps, which is right. Which means that this temperature is probably accurate. Can somebody look up what 12 degrees Celsius is?
Yeah, I see. Converting Celsius to Fahrenheit.
Just under 64. 1.8 times 12, which almost 2 plus 32.
Yeah, it's 53.6.
Okay, so it's off, but at least it's reading now. And then so if I heat that temp probe up, I should see that current go up, right?
Should.
Well, I'm guessing what happened is the lead that I had plugged in to the module either was not making good connection. It was just, operator error, poor wiring. Well, heat that probe up. If we see our current go up, can you read the meter or no?
Kinda. See a 6.
Tell me if that current starts going up.
It is. It already went from 6 to 11.
I'd say we're good. So if I hook that probe back up and we look in RS Logics with it running, hopefully, no, it is reading. Look at that. 32 degrees Celsius. 99 degrees Fahrenheit. I think we're okay.
Dawn, is that yours again?
Yeah, it always is.
Boy, like,
Cool. I think we fixed it. Good job, class.
Good job,
yeah.
Zach.
Okay. We're reading at 20 degrees Celsius and says showing 17. 63 degrees Fahrenheit. Okay, so where were we? We need to run the process now.
Yeah.
All right, Zach. Oh, we're already running. Okay. What do I need to do? How do we run the process? Somebody who has the process pulled up, tell me.
I'm looking for it.
I don't have it pulled up right now.
I don't have that one pulled up. I got all the other stuff pulled up. Let me do.
So selector switch left enables entire process turning the water.
Right now the soldering iron's on, right? Because the pilot light is flashing, the red pilot light's flashing.
Yes.
We should
I'm
see
reading through
degrees
it.
Fahrenheit start to rise. And then when we get to 80, then the soldering iron should turn off, right?
Yes.
Well, we're at 80. Oh, no. Oh, 80.
Didn't the cooling fan turn on?
get to 120, it'll turn on. Can you hear what's happening?
Yes.
It's clicking on and off. So we're going to get to 80, but we're not going to get to 120.
That's
We
fine.
need to adjust the numbers because of that lag that's going to be in there.
So add a timer maybe.
No, I think we go down to the rungs. Do we have the numbers turning on the soldering iron? Temp heater, so rung 12. Right now we're telling it when the temperature gets up to 14,548, turn the temperature heater on, or below 1548, 14,548. See that? But right now it's off, but you'll see the temperature start to fall. When it gets below that number, it will kick on. Wait for it. Now it's on. So what did we talk about doing the last time? Maybe you said timer, Brady?
I suggested that. Last time, I don't know. But I meant today.
I thought Jake had talked about like you don't turn it off until it hits that temperature, that high temperature, and then you turn the fan on until it gets to the lower temperature.
So instead of having it at 80, put it at 120. Then at the same time have the fan do that, and then the fan turn off at 80. So it just stays in between those two ranges.
But you also need to have it to where they're not both on at the same time.
So put it in series with well, then it turn off once it.
Well, let's create a 10-second timer. Here's what I'm thinking. We create a timer that at the end of whatever we decide, but I think we started with 10 seconds. At the end of 10 seconds, it will read the temperature, right?
Right.
And
so it won't click on and off.
Yeah. So you see how, look on rung 12, you see the temp sensor, the source. You see how it's changing every split second?
Yes.
We want it to do that
different speed
every 10 seconds. So how do we do that?
Create a different timer and then put that in series.
Use the done bit. So we need a timer that just sits there and counts to 10, right?
All right.
And then every 10 seconds, the done bit will
activate.
Well, yeah.
I guess that's.
We'll move. So let's create a timer. Let's add a rung there, Zach, somewhere.
Okay.
Let's go offline while we do this.
All right. Okay.
You got to click on the rung. There you go.
Does it matter which one I do?
Well, we need to just grab one that we're not using yet. So we've labeled 4 and 5, but I don't know if we've used 1, 2, or 0, 1, 2, or 3 yet. I'm
I
assuming
think we
we've
used
used
0 and
4 of
1.
them because we have a half-second timer and we have a 0.2-second timer. So let's go look and see what our so T40, T41, and then find the other timers. T44 and T45. So let's go into controller tags on the left,
Controller tag.
and let's put a description into T40 and T41. Yeah. And just call it, what is that? Process on, is that what it is? Control on flash.
Okay.
And then the next one would be control on flash 2. Now we can pick either T42 or T43 and label that just like sensor read timer. We're going to start with 10 seconds, but we might adjust it. Cool. So then we're going to use T42 for the timer that we're using.
Okay.
Zach, is this why we label things while we go?
I think so.
Okay, I was just checking.
He's got jokes.
Well, was John the one we're voting to kick in the chat today?
Hey, no, that was a serious question. Don't kick me.
I think Don gets to decide since he got voted out yesterday.
I think we should vote Don out again today.
Yeah, I passed go. I collected my $200. I'm good.
Hey man, no. If your kid starts hollering and screaming again, though, you're gone. You're done.
Oh, well, let me go get him on the mics then.
Don't sound too eager. Oh my goodness.
Okay, so we got a 10-second timer on it. And then what's going to make that thing reset?
Can't we do a reset rung where when it reaches its preset, it will just reset itself?
Timer timing.
You could put a T42 done instruction in front of it.
I didn't even think about that. But would that reset it though? Wouldn't it just stay at the same accumulated number?
If you use that one,
If it's examinative open. Yep.
Okay.
What do we want to happen every 10 seconds?
We want to read temperature.
Yeah.
So then we need to find the temperature sensor, right?
Mhm.
And then use that timer timing bit.
So put the timer timing bit before this.
No, because that rung is to turn the heater on.
Probably run 16.
We want to either control when the temperature sensor is
That's
red.
B32.
So it'd be before this one.
What are we using B32
Maybe. Yeah.
just to turn the temperature fan on? Which rung are we? Which rung can we put this in? Scroll down a little bit. Nope, can't put it down there.
Yeah, just scroll up. It's at the top.
Nothing in there. Go back down. Stop. Go back up a little bit. Stop. Can we put something in any of these rungs? 8, 9, 10.
I mean, we could. Because that's our temperature, right?
Yeah. What are we doing in rung 8?
Reading
Computing.
Celsius. Or, yeah, computing
So
from the temp
T2.
sensor.
From the temp sensor.
Yeah.
But what if we told it, okay, only do that calculation every 10 seconds?
So then put that timer timing bit before that compute function.
Yeah. Or done bit.
Yeah.
Done bit.
Yep.
Yeah, Zach, if it was me, I would probably put that done bit on line 8 for the compute Celsius.
That's a good idea.
John, I don't think any of us would have thought of that. Thank you.
Oh, you're welcome, Brady. That's why I put my 2 cents in, brother.
Still get $1 back.
I think we might have problems with it, but we can run and see what happens.
That would be all right.
So let's go ahead and run that and see what happens. See if it reads the temperature every 10 seconds. Yep. Think on the next one we'll get the temperature to turn off.
Yes.
How come it never turned off? Did it?
No, never did.
feel like we're going to be waiting forever.
Oh boy.
It's just sitting at. Okay, we're below 80. Why is it not kicking on?
Are we using it being the measured value as something causing something to work later on? Like, are we using the temp sensor data?
Yeah, okay, so here's turn the heater on. We're below this number. Why is temp control run bit B31 not energized?
The bottom red pilot light isn't either.
Oh, because I didn't push the push button. Process control is not on. Come on, Zach. Now we're running.
Yeah, Zach, I was looking. You didn't turn on process control.
Thanks, John. Why is it still clicking on and off?
Maybe because of run 3.
That's why. We're using the temp sensor instead of this. So we need sensor read timer T42 done on that same run, right? Hey?
Right.
Mm-hmm.
Isn't that gonna throw off your heater though? Because it's only turning on when that sensor reads, or the timer is done.
Yeah, but that's what we want, right? We only want it to turn on every 10 seconds. Wait a minute. Yeah. Right?
I guess my serious question is, again, hey guys, quiet down so I can talk. If we're trying to keep it between that window, why don't we just have it turning on and staying on until it's close to the end of that window? I said, how come we don't have it just turning on and staying on until we get to a desired temperature or temperature range?
So like stay on till 100 degrees for both of them.
You mean having a target temperature in the middle of the range instead of...
Yeah, or something to that.
Yeah, let's do it.
Degree. I mean, I don't know.
Let me show you guys how to use Excel for handy interpolation. What are our numbers for the temperature sensor input? 4 to 20 milliamps.
Hold on, I gotta pull them up.
41 and 31208. And if this is 0,
Yeah.
this is 100. If we have input and we have a temperature, so what would our formula be for this? If we said that this,
That would be our max, so that'd be 120.
equals this minus this. Divided by this minus this. That would give us a percentage, which would also give us degrees Celsius, right?
Yes.
So if we had an input of 6,000, or 10,000, be 15 degrees Celsius. So I guess we'd have to take this whole thing times 100. See what I'm doing? Instead of having to do the math every time.
Yeah. You lost me at 100 though. Why are we? Oh, because the
Instead of
top
outputting
range.
percentage, we want a temperature.
Yeah.
Input 1,000, we get an output of 15.05 degrees Celsius. So what if we wanted to input a temperature and know what number we needed in this range? So what would this be? This would be
the inverse, so you would subtract it from the big number and divide.
It would be this percentage times this range, right?
Yeah.
That too.
So it would be D3 divided by 100 times that.
Minus 3, A3.
Minus A3. Plus the bottom number.
So plus A3 after that. Sorry, that was me.
So right now we're at 0, the number 6241. But if we wanted the temperature to be at something degrees Celsius, let's say we wanted it at 50 degrees Celsius, our number would be 18724.5. Does that make sense?
Yes, that does.
So now that we have this handy tool made up, what are we trying to do again? I forget. Oh, we're going to shoot for 100 degrees Celsius. Is that what we're doing?
Yeah.
John?
Yes.
Yeah.
I have one more slides.
So what's 100 degrees Celsius? No, we want 100 degrees Fahrenheit. What's the formula for Celsius to Fahrenheit?
Subtract 32 times
Multiply.
5 divided by 9.
Yeah, 5/9.
What is it?
Subtract 32 and then multiply
Times 9/5
by 5/9.
times 5/9.
Yeah.
Stuck.
Celsius to Fahrenheit is Celsius times 1.8 plus 32.
Wow, you're smart.
Oh, were we going from Fahrenheit to Celsius then?
We're going from Celsius to Fahrenheit, right?
Yeah,
Yeah.
1.8
So we
plus
said
32.
yeah. We went the wrong way. That's what I was saying.
I thought you said Fahrenheit to Celsius. My
Yeah,
bad.
it's all
What is it?
It's plus 32.
Times 1.8.
Wait, that's 9/5.
yeah, that's the same either way.
Yeah, so that's the right one.
No, because 0 degrees Celsius is not 57.6 degrees Fahrenheit. I think it's times 5/9. Oh, it's 5/9 degrees Fahrenheit. Wait a minute, what?
You don't even have a number in for Celsius.
I know, but it's 0.
Is it going to assume 0? No, it does not. Does it?
Yeah, it assumes 0.
Assume 0?
It should
Okay.
be 9/5 plus 32.
9/5 F2 plus 32. Oh, okay. So
Which 9/5 is 1.8.
times this.
So we had the order of operations wrong.
Yeah. If I put in 100 here, it should be 212 Fahrenheit. Right. Okay.
Yeah, okay, good.
So then what's the opposite then? We wanted to take Fahrenheit and convert it to Celsius.
So that's whenever you do 9/5 times the Celsius number minus 32.
Uh-oh.
Do you have to have it in print? No?
It's G3 minus 32 times 9/15. Boom.
Oh, that's weird. Okay.
That's what we need to input. That's what we need to input. That's what we need to input. Okay, so what we want to know what 100 degrees Fahrenheit is. 122.4. So if we want 122.4,
Wait, how is 122.4 in Celsius 100 in Fahrenheit? If 100 in Celsius is 212 in Fahrenheit.
I don't know.
That doesn't, yeah. Whoa, whoa. Calm yourself.
Shut up, Kenzie.
Hi, Nate.
You don't even play video games with me and Luke anymore.
When's the last time you guys invited me to?
We invite you all the time.
No, you don't. Plus, my connection at the dorm isn't good enough to play. You guys should have asked whenever I was at home.
No, it is good enough to play. I used to play video games with Luke all the time at the dorm.
You had your own router. Your router was better than mine.
No, I just stuck a LAN cable in.
Because we couldn't even play Animal Crossing.
That's because Nintendo has terrible internet
There we go.
services.
So
Okay, that's better.
if we had temperature of this 37.78, our number needs to be 15,673. Got it?
Got it.
Got it.
Turn heater on. If this is less than
673. 15,673.
673, turn that on. And if where's the turn the fan on? This is greater than 15,673. Yeah?
Yeah.
Yeah.
Or do you want some overlap so we can see if we can draw as much current as possible and burn that sucker down?
Yeah, we should do that.
Yeah, let's do that.
Where is our why isn't our temperature heater turning on?
Did you hit auto start this time?
Yep. Did you hit the green button?
Yeah.
Okay.
I gotta head out because I gotta get back to work.
Bye, Kenzie.
Is there gonna be much after this?
No, because it's 11:10.
Yeah, I know it's 11:10. That's why I'm going back to work, Nate.
Stop yelling at me.
You can get me first.
I don't like when mom and dad fight.
Turkey.
We're not fighting, Luke. We're just having a discussion.
We're just mad, but I gotta get going. So if class is over, I gotta go. And if class is over, then I'll just finish it on the YouTube video. Okay, bye.
Bye.
It's all your fault, Nate.
Okay, so
Tom, don't.
right, when we get to 100 degrees Fahrenheit, the soldering iron should turn off and the exhaust fan should turn on. Where's our temperature in Fahrenheit?
Right there. 72.
Why are both fans on?
Bottom one's the exhaust fan. I'm wondering why the temperature heater and the exhaust and the air temp fan are both energized. We're less than we're less than 100 degrees. Why is the
Oh my.
Oh, because we didn't move it to 0. See what happened?
Yep.
Somebody explain that to me.
So the
Just turn the process off.
Yeah.
Why is that fan still running?
Because the heater flash.
Because you moved the number into the file, basically say turn it off, turn it on, and you don't have another move function moving another number to that file saying turn it off, correct?
Right.
Oh.
So should we put that timer done bit in front of this?
Yes, because then it just flash, wouldn't it? Turn on and off.
So it's not reading the temp sensor?
Constantly.
Otherwise, I have a feeling we're going to get to 100 and we're going to turn the fan off, go back to heat. Turn the fan off, go back to heat. You know what I mean? T42. We also want to do it for the heater on. Every 10 seconds, this is becoming true and then going back off. Uh-oh. Oh, we'll have to fix that next time. I think we're close.
Then it's on the HMIs, correct?
Yeah, once we get this dialed in, we'll move on to the HMI. We'll design something for this process using the tags in the system that we have here. Fun, huh?
Yeah.
Thanks, Brady. All right.
All right, guys. Appreciate it, Zach.
Bye, everyone.
Till next time. I do have one question. Does anyone know if Bass Pro's open? Since they're not
Yeah, they
essential?
are.
All right, cool.
They're essential. Buying a new gun?
I can't, but